Here's one more example of an indefinite integral with a u-substitution. We're going to integrate x squared over the square root of 1 plus x dx. All right, so for this, you first need to choose what you want u to be. And there's a couple places you might start here, seeing how we have an x squared and an x. That's tempting for a lot of folks because they see the x squared and they're like, oh, well, if u is x squared, then du would be 2x dx. But notice how that's actually not going to help us too much because our x dx would be together here if we use this substitution. And in the actual problem, x is in the denominator and underneath the square root, while dx is neither of those things. So x and dx are not together like this. Also, that would mean like you're somehow trying to put a du down here, but we don't want to have like a floating du inside a square root and nothing to do with the dx. So this turns out to not be a very good substitution. But you may try it and see that, hey, it doesn't actually work. And so then we try something else. That's just kind of how these problems go sometimes at first. So let's use an approach that's similar to our last example we saw, where we made u into the complicated bit of the integral. The stuff that was underneath the square root in this integrand was what was complicating this problem for us. So if we use a similar approach here, we can just take whatever's underneath our square root in this new problem and let that be u. Okay, so let's let u equal 1 plus x. That'll at least simplify the square root for us. That's good. All right, so this part is covered. That is u in there. Okay, let's take the derivative here. That's your next step. Du dx would be 0 plus 1. Okay, so just 1. And that would tell us that du equals dx. Okay, so that'll take care of this dx right here. All right, dx is going to get replaced with du because the two of them are equal. Cool. But we've still got a big glaring thing that is missing here. It's the x squared on top. That's still in terms of x, not u. And we really need to convert everything over into terms of u. So what is this x squared going to be? All right. So sometimes these take a little bit of creativity to work around and get everything converted, but everything will go through your u substitution in some way or another. So u is 1 plus x. We could solve this for x. Okay, x would be u minus 1. And so x squared is going to be u minus 1 getting squared. Or you could say that's u squared minus 2u plus 1. And that is going to cover this x squared in the numerator there. This is u minus 1 squared, or u squared minus 2u plus 1. Okay, so when we convert our integral, it looks like this. The integral of, in the numerator there, u squared minus 2u plus 1, all over the square root of u, and then the dx gets replaced with du. Okay, so it looks like this. u squared minus 2u plus 1. Let's rewrite that square root. We know we usually do. And so that would be u to the 1/2 in the denominator times du. And then we can approach this with a little bit of division, a little bit of simplification here. So let's divide all our terms in the numerator by u to the 1/2. Split it all up. Okay, this would be the integral of u squared over u to the 1/2 minus 2u over u to the 1/2 plus 1 over u to the 1/2 du. Okay, and then we can simplify each one of those. U squared over u to the 1/2 would be u to the 3/2. And then we'd subtract 2 u to the 1/2 there and add u to the negative 1/2 du. And doesn't that indefinite integral look quite a bit better? I think it does. We just got to use our power rule in reverse now. So much better. So we would end up with u to the 5/2, throw a 2/5 out front, and then minus 2 times, okay, we'd have u to the 3/2, throw the 2/3 out front there, and then plus, we'd have, okay, u to the positive 1/2 and throw a 2/1, or just a 2 out front there, and don't forget your plus c. Okay, let's clean it up. All right, 2/5 u to the 5/2 minus 4/3 u to the 3/2 plus 2u to the 1/2 plus c. And although that might feel really good, we're not quite done yet. The last thing we've got to do, remember, is to go back through our substitution and put things back in terms of x. So all of our u's there need to get replaced with 1 plus x. Okay, so that is going to look like this. We're going to have 2/5 1 plus x, oops, 1 plus x to the 5/2 minus 4/3 1 plus x to the 3/2 plus 2 1 plus x to the 1/2 plus c, or any equivalent form of this. There are definitely a lot of other ways that this could be written, but as far as getting the antiderivative or indefinite integral goes, this puts us at that stage. Everything has been anti-derived, I suppose, anti-differentiated. And we've gotten everything back in terms of our original variable x. So this is good. This answer or any equivalent form. There we go.